We've reached the end of another skill, so let's review what we've learned by taking a quiz. First up out of 5 questions. Which tag or tags will result in a frame landing in the best effort queue? Okay, if we're not careful about this one, we might actually miss this, because our inclination might be to say that, well, best effort, that would be a class of service value of 0. But we're actually going to take any class of service value that doesn't get matched by a previous traffic class. If, for example, we enable platinum, and platinum covers 5, and we enable gold, and gold covers 4, but we only enable these 2 traffic classes, and we've got best effort down here, well, it's going to serve as a catch-all, meaning it's going to take any packet that shows up that doesn't fall into one of those categories. So in this case, we would take a COS tag of 0, or 1, or 2, or 3. Remember that 6 and 7 are already reserved, and so we're not going to be taking those. But at the same time, platinum and gold, those are the only ones that we enabled. And as a result, best effort will take anything else that we haven't activated. Question 2. What mechanism enables a network device to choose to send one packet over another? So all of these have something to do with quality of service. However, it's the creation of multiple queues that really enables us to schedule out different packets. Remember, if we have a first in, first out queue, that first in, first out queue is just a bunch of packets in a row. And if this packet needs to get sent next, we have no way of doing that. We're going to have to send this packet first, and then this one second, and then this one third, and then we can get to our important packet. It's the creation of multiple queues, so now we've got lots of queues here, and the scheduler can pick from any one of these queues, depending on which one it needs to service based on bandwidth reservations and priority status and such. So see, creating multiple queues, that is the magic that enables us to pick one packet over another. Question 3. The following QoS design needs to be added to UCS. What weights should be used for each traffic class? Okay, so there's no disguising it. This is a math problem. We need to find weight values that we can use to divide up a particular link bandwidth by the percentages that are listed. Now, usually what we can do is we can find the least common denominator kind of concept here. And so we look at 12.5%, for example, that's 1/8, and silver is 1/4. Except 1/8 is using a larger denominator, so maybe we should go with that. So silver, we can call this as 2/8. Bronze, we can call as 3/8. And best effort would also be 2/8. Now, if we add these up, it should be 100%. And so not only from a percentage perspective, but also from a fraction perspective. So 1/8 plus 2 plus 3 plus 2, that is 8 out of 8. So that would be a whole number, which is 100%. So once we have the denominators all in line with one another, we can just simply take the numerators as our weights. And so we can say 1, 2, 3, and 2. Now there's no reduction to be done here. If there was, then we could do that. So at this point, this is our answer. However, if for any reason we were to go to the fabric interconnects and enter weight values of, let's just say 2, 4, 6, and 4, well, this would work because the weight ratios are the same. However, we would prefer to reduce it down as much as possible. And so 1, 2, 3, and 2, that would be our answer here. Next up, what mechanism is used by Nexus and fabric interconnects for congestion management? This congestion management is really talking about what type of queuing we're using. So FIFO is technically a congestion management technique. It's not a great one. And as for the rest of these are real congestion management techniques. However, priority queuing is a legacy one. We don't use that a whole lot anymore. And low latency queuing, this is actually used for voice over IP out in the iOS world, but we can't actually deploy that on Nexus devices. So in this case, the more you know, the more you might have tripped yourself up, because low latency queuing is a very valid technique outside of the data center. However, inside the data center, we are simply relying on class-based weighted fair queuing, and so D, that is our answer. And last question, what setting must be enabled in order to wipe out incoming class of service tags from a downstream server? Well, this is going to have something to do with host control, and so we just need to remember which option is which. And the idea here is that, are we giving the host control over those tags? So if we say host control full, then we are trusting that. So full is equal to trust. However, if we don't want the host to have any control over the tagging of our packets, well, then we'd want to say none. So this is no trusting. And so the question is asking which one allows us to override. Well, that would be the no trust situation. So A is our answer. Well, that wraps up this quiz. If you find yourself just a little bit congested as far as trying to absorb all of this information, then be sure to go back and watch the appropriate videos in order to reclaim those lost packets. Otherwise, congratulations on completing Explain UCS Quality of Service. I hope this has been informative for you. I'd like to thank you for viewing.